numbers. Before starting with our actual topic, let us understand with the basic first. First, natural number denoted by n. Here, n is equal to 1, 2, 3, 4 and so on. Second, whole number, which is denoted by w. Here, w is equal to 0, 1, 2, 3 and so on. Third, integer, which is denoted by I. Here, I is equal to -3, -2, -1, 0, 1, 2, 3 and so on. Rational numbers. The set of fraction is called a rational number. Here, q is equal to p by q, where p and q belongs to integer and q is not equal to 0.
Order relation on rational numbers.
If ps is equal to qr, then p by q is equal to r by s. If ps is greater than qr, then p by q is greater than r by s. Properties of rational numbers. A. Properties of addition of rational numbers. If a, b and c are any rational numbers, then let us assume that a is equal to 3, b is equal to 4 and c is equal to 5. First, commutative property, which is a plus b is equal to b plus a. Therefore, 3 plus 4 is equal to 4 plus 3 and hence 7 is equal to 7. Second, associative property. A plus b plus c is equal to a plus b plus c. Therefore, 3 plus 4 plus 5 is equal to 3 plus 4 plus 5, which is 7 plus 5 is equal to 3 plus 9, which comes to 12 is equal to 12. Third, additive identity. A plus 0 is equal to 0 plus a, which is equal to a. Fourth, additive inverse. A plus minus a is equal to 0. For example, 3 plus minus 3 is equal to 0. B. Properties of multiplication of rational numbers. Here, let us assume a is equal to 3, b is equal to 4 and c is equal to 5. First, commutative property. A into b is equal to b into a. Therefore, 3 into 4 is equal to 4 into 3, which is 12 is equal to 12. Second, associative property. A into b into c is equal to a into b into c. So, 3 into 4 into 5 is equal to 3 into 4 into 5, which is 12 into 5 is equal to 3 into 20. Therefore, 60 is equal to 60. Third, multiplicative identity. A into 1 is equal to 1 into a, which is equal to a. Fourth, multiplicative inverse. A into 1 by a is equal to 1 by a into a, which is equal to 1.
Decimal form of any rational number is either terminating or non-terminating recurring type. Terminating type. 2 divided by 5 is equal to 0.4. Minus 7 divided by 64 is equal to minus 0.109375. 101 divided by 8 is equal to 12.625. Non-terminating recurring type. 17 divided by 36 is equal to 0.472222, which is equal to 0.472. 33 divided by 26 is equal to 1.269 1.260,769,230,7, which is equal to 1.2692307 bar. 56 divided by 37 is equal to 1.513513513, which is equal to 1.513 bar.
Irrational numbers. Numbers which are not rational numbers are called irrational numbers. For example, square root of 2, square root of 3 and square root of 5. Note: decimal fractions with non-terminating and non-recurring, that is 0.011, 0111, 00 and so on. Now we will start with our actual topic, real numbers. Rational numbers and irrational numbers.
Properties of irrational numbers. Addition or subtraction of a rational number with an irrational number is an irrational number. Multiplication or division of non-zero rational number with irrational number is also an irrational number. Addition, subtraction, multiplication and division of two irrational numbers can be either a rational or an irrational number.
Properties of order relation on real numbers. First, A is equal to B, or A is greater than B, or A is less than B. Second, suppose A is equal to 3, B is equal to 4, C is equal to 5. Therefore, if A is less than B and B is less than C, then A is less than C. For example, 3 is less than 4, 4 is less than 5. Therefore, 3 is less than 5. Third, if A is less than B, then A plus C is less than B plus C. For example, 3 is less than 4. Then 3 plus 5 is less than 4 plus 5. Fourth, let A be less than B. First, if C is greater than 0, then AC is less than BC. For example, 3 by 5 is less than 4 by 5. And second, if C is less than 0, then AC is greater than BC. If C is equal to minus 2, then 3 into minus 2 is greater than 4 into minus 2.
Square root of a negative number. We know that if square root of A is equal to B, then B square is equal to A. Hence, if square root of 5 is equal to x, then x square is equal to 5. Similarly, we know that square of any real number is always non-negative. It means that square of any real number is never negative. But square root of minus 5, the whole square, is equal to minus 5. Therefore, square root of minus 5 is not a real number. Hence, square root of a negative real number is not a real number. Root of positive rational number. We know that if x square is equal to 2, then x is equal to square root of 2, or x is equal to minus square root of 2, where square root of 2 and minus square root of 2 are irrational numbers. Thus we know 3 square root of 7, 4 square root of 8, these numbers are irrational numbers too. If n is a positive integer and x raised to n is equal to a, then x is the nth root of a. X is 5 square root of 2. This root may be irrational or rational. For example, 2 raised to 5 is equal to 32. Therefore, 2 is the fifth root of 32. But if x raised to 5 is equal to 2, then x is 5 square root of 2, which is an irrational number. Rationalization of the denominator. The product of conjugate binomial surds is always a rational number. By using this property, the rationalization of the denominator in the form of binomial surd can be done. Example 1. Rationalize the denominator 1 upon square root of 5 minus square root of 3. Solution. The conjugate pair of square root of 5 minus square root of 3 is square root of 5 plus square root 3. 1 upon square root of 5 minus square root of 3 is equal to 1 upon square root of 5 minus square root of 3 multiplied by square root of 5 plus square root of 3 upon square root of 5 plus square root of 3, which is equal to square root of 5 plus square root of 3 upon square root of 5 the whole square minus square root of 3 the whole square is equal to square root of 5 plus square root of 3 upon 5 minus 3 is equal to square root of 5 plus square root of 3 upon 2. Example 2. Rationalize the denominator 8 upon 3 square root of 2 plus square root of 5. Solution. The conjugate pair of 3 square root of 2 plus square root of 5 is 3 square root of 2 minus square root of 5. 8 upon 3 square root of 2 plus square root of 5 is equal to 8 upon 3 square root of 2 plus square root of 5 multiplied by 3 square root of 2 minus square root of 5 upon 3 square root of 2 minus square root of 5 is equal to 8 3 square root of 2 minus square root of 5 upon 3 square root of 2 the whole square minus square root of 5 the whole square is equal to 8 multiplied by 3 square root of 2 minus 8 square root of 5 upon 9 multiplied by 2 minus 5 is equal to 24 square root of 2 minus 8 square root of 5 upon 18 minus 5 is equal to 24 square root of 2 minus 8 square root of 5 upon 13.
Absolute value. First, modulus of x is equal to x for x is greater than 0. For example, if x is equal to 5 greater than 0, therefore modulus of 5 is equal to 5. Second, modulus of x is equal to minus x for x is less than 0. Third, modulus of x is 0 for x is equal to 0. Surds. Irrational root of a positive rational number is a surd. Nth root of a or a raised to 1 by n if n belongs to n where n is not equal to 1. Note, n is the order of surd, a is the radicand, and square root is the radical sign. If n is equal to 2, then it is a quadratic surd. Similar surds or like surds. P nth root of a and q nth root of a where p and q belong to q. For example, 3 by 7 root 2 minus 12 root 2 are similar surds. Simplest form of a surd. Comparison of surds. Surds of same order can be compared. First, nth root of a is equal to nth root of b if a is equal to b. Second, nth root of a is greater than nth root of b if a is greater than b, and nth root of a is less than nth root of b if A is less than B.
Operations on like surds. Mathematical operations like addition, subtraction, multiplication and division can be done on like surds. Example 1. Simplify 7 square root of 3 plus 29 square root of 3. Solution: 7 square root of 3 plus 29 square root of 3 is equal to 7 plus 29 square root of 3 is equal to 36 square root of 3. Example 2. Simplify 7 square root of 3 minus 29 square root of 3. Solution: 7 square root of 3 minus 29 square root of 3 is equal to 7 minus 29 square root of 3 is equal to minus 22 square root of 3. Example 3. Simplify 13 square root of 8 plus 1 upon 2 square root of 8 minus 5 square root of 8. Solution: 13 square root of 8 plus 1 upon 2 square root of 8 minus 5 square root of 8 is equal to 13 plus 1 upon 2 minus 5 square root of 8 is equal to 26 plus 1 minus 10 upon 2 square root of 8 is equal to 17 upon 2 square root of 8 is equal to 17 upon 2 square root of 4 multiplied by 2 is equal to 17 upon 2 multiplied by 2 square root of 2 is equal to 17 square root of 2. Example 4. Simplify 8 square root of 5 plus square root of 20 minus square root of 125. Solution: 8 square root of 5 plus square root of 20 minus square root of 125 is equal to 8 square root of 5 plus square root of 4 multiplied by 5 minus square root of 25 multiplied by 5 is equal to 8 square root of 5 plus 2 square root of 5 minus 5 square root of 5 is equal to 8 plus 2 minus 5 square root of 5 is equal to 5 square root of 5. Example 5. Multiply the surds square root of 7 multiplied by square root of 42. Solution: square root of 7 multiplied by square root of 42 is equal to square root of 7 multiplied by 42 is equal to square root of 7 multiplied by 7 multiplied by 6 is equal to 7 square root of 6. 7 square root of 6 is an irrational number. Example 6. Divide the surds. Square root of 125 divided by square root of 5. Solution: square root of 125 upon square root of 5 is equal to square root of 125 upon square root of 5 is equal to square root of 25 is equal to 5. 5 is a rational number. Example 7. Square root of 50 multiplied by square root of 18 is equal to square root of 25 multiplied by 2 multiplied by square root of 9 multiplied by square root of 2 is equal to 5 square root of 2 multiplied by 3 square root of 2 is equal to 15 multiplied by 2 is equal to 30. Note that product and quotient of two surds may be rational numbers which can be observed in the above example 6 and example 7. Rationalization of surd. If the product of two surds is a rational number, each surd is called a rationalizing factor of the other surd. Example 1. If surd square root of 2 is multiplied by square root of 2, we get square root of 2 multiplied by 2 is equal to square root of 4 square root of 4 is equal to 2 is a rational number. Therefore, square root of 2 is rationalizing factor of square root of 2. Example 2. Multiply square root of 2 multiplied by square root of 8. Square root of 2 multiplied by square root of 8 is equal to square root of 16 is equal to 4 is a rational number. Therefore, square root of 2 is the rationalizing factor of square root of 8. Similarly, 8 square root of 2 is also a rationalizing factor of square root of 2. Because square root of 2 multiplied by 8 square root of 2 is equal to 8 square root of 2 multiplied square root of 2 is equal to 8 multiplied by 2 is equal to 16. Square root of 6, square root of 16, square root of 50 are the rationalizing factors of square root of 2. Example 3. Find the rationalizing factor of square root of 27. Solution. Square root of 27 is equal to square root of 9 multiplied by 3 is equal to 3 square root of 3. Therefore, 3 square root of 3 multiplied by square root of 3 is equal to 3 multiplied by 3 is equal to 9 is a rational number. Therefore, square root of 3 is the rationalizing factor of square root of 27. Note that square root of 27 is equal to 3 square root of 3 means 3 square root of 3 multiplied by 3 square root of 3 is equal to 9 multiplied by 3 is equal to 27. Hence, 3 square root 3 is also a rationalizing factor of square root of 27. In the same way, 4 square root of 3, 7 square root of 3 are also the rationalizing factors of square root of 27. Out of all these, square root of 3 is the simplest rationalizing factor. Example 4. Rationalize the denominator of 1 upon square root of 5. Solution. 1 upon square root of 5 is equal to 1 upon square root of 5 multiplied by square root of 5 upon square root of 5, which is equal to square root of 5 upon 5. Multiply numerator and denominator by square root of 5. Example 5. Rationalize the denominator of 3 upon 2 square root of 7. Solution. 3 upon 2 square root of 7 is equal to 3 upon 2 square root of 7 multiplied by square root of 7 upon square root of 7 is equal to 3 square root of 7 upon 2 multiplied by 7, which is equal to 3 square root of 7 upon 14. Multiply 2 square root of 7 by square root of 7 is sufficient to rationalize. Binomial quadratic surd. Square root of 5 plus square root of 3, 3 upon 4 plus square root of 5 are the binomial quadratic surds form. Square root of 5 minus square root of 3, 3 upon 4 minus square root of 5 are also binomial quadratic surds. Study the following examples. Square root of a plus square root of b, square root of a minus square root of b is equal to square root of a the whole square minus square root of b the whole square is equal to a minus b. Square root of 5 plus square root of 3, square root of 5 minus square root of 3 is equal to square root of 5 the whole square minus square root of 3 the whole square is equal to 5 minus 3 is equal to 2. Square root of 3 plus square root of 7, square root of 3 minus square root of 7 is equal to square root of 3 the whole square minus square root of 7 the whole square is equal to 3 minus 7 is equal to minus 4. 3 upon 2 plus square root of 5, 3 upon 2 minus square root of 5 is equal to 3 upon 2 the whole square minus square root of 5 the whole square is equal to 9 upon 4 minus 5 is equal to 9 minus 20 upon 4 is equal to minus 11 upon 4. The product of these two binomial surds, square root of 5 plus square root of 3 and square root of 5 minus square root of 3 is a rational number. Hence, these are the conjugate pairs of each other. Each binomial surd in the conjugate pair is the rationalizing factor for the other. Note that for square root of 5 plus square root of 3, the conjugate pair of binomial surd is square root of 5 minus square root of 3 or square root of 3 minus square root of 5. Similarly, for 7 plus square root of 3, the conjugate pair is 7 minus square root of 3 or square root of 3 minus 7.